We will now proceed to the second group of physiological protein, and these are the globular proteins. Now, I have mentioned last meeting that globular proteins, they play a significant role also in our body. Particularly, they are very important to perform metabolism processes. Okay, metabolism. Okay, what else? Is also very important for transport. Okay, transport purposes. And we also have globular proteins for storage. Okay, for storage purposes. Okay, so we have metabolism, transport, storage. Now, with regards to these roles or special functions of globular proteins, we will focus more on the transport and storage roles ng globular proteins. Okay, and with regards to transport and storage, okay, we will discuss this special role nila in relation to oxygen molecule. Okay, in relation to oxygen molecule, yung function nila towards transporting oxygen and storing oxygen. Okay, now we all know that oxygen in our body, that is very important for survival purposes. Diba? Lahat ng tissues, walang exemptions, lahat po ng tissues in our body, cells in our body requires oxygen. Okay, so with that, let us have first the slide. Okay, so with regards oxygen, I repeat, this is very important for cellular respiration. Okay, so this is somehow a basic knowledge to every one of us. Importante po ito for cellular respiration. Okay. However, oo nga, kailangan natin ng oxygen. Okay, in our body, kailangan po siya ng different cells, different tissues. It has to be distributed. However, yung problem dito, yung problema with oxygen is marami siyang challenges na pwedeng ma-encounter, especially upon distribution. Kumbaga, in our way of saying that, si oxygen, hindi siya basta-basta nade-distribute. Okay? Hindi siya basta-basta nade-distribute. So, bakit? Okay, why is it yung oxygen, meron siyang mga problems being encountered? So, what are those? So, number one, take note, yung oxygen, hindi po siya humahalo sa aqueous solution. Okay, hindi siya basta-basta humahalo sa aqueous solution. So a very good example of aqueous solution that I am talking about is yung blood. Okay, or yung plasma. Blood or plasma, that is just synonymous terms. Okay? Isa yung aqueous solution. So yung oxygen gas, hindi po yan basta-basta na muhalo, mumix, okay, with blood. Okay? Another thing, with that problem, kung hindi siya basta-basta humahalo sa blood, talagang lisod siya, ma-distribute. Diba? Another thing, if ever, kung sumama naman siya sa blood, okay, yung problema naman is hindi significant yung quantity that is being distributed to the tissues. Okay? Kapag humalo naman siya sa blood, hindi ganoon karami yung nade-distribute na oxygen sa tissues. Okay? And last problem that oxygen encountered is that it is said to be distance dependent. Okay, this is distance dependent. Now, when we say distance dependent, konting space lang, konting layo lang ng oxygen gas sa mismong tissues, okay, hindi na yan made-distribute. Okay, it will not allow diffusion already of oxygen. Kung medyo layo siya, gamay sa tissues, then dili na siya ma-distribute on that particular tissues of interest. So, kumbaga, distance dependent siya. Okay, so these are the problems being encountered by oxygen. Okay, ngayon, with that being said, okay, paano nagagawa ngayon ng oxygen, okay, para ma-distribute siya to the different cells, to the different tissues in our body. So yung goal ngayon, yung solusyon dyan, bakit siya na-distribute sa different tissues in our body is number one, okay, yung number one or the first goal, okay, is dapat yung oxygen gas na yan, dapat samahan niya ng protein. Okay? That's the first goal. Okay? I repeat, yung oxygen na hindi basta humahalo sa blood, okay, dapat it has to go along with a protein. Okay, so no problem with that term protein, you know that already. What is again the monomer units of protein? Ano yung mga monomer or basic structure of protein? Very good, amino acids. Alright? So we all know that proteins, it is consist of amino acids. Alright? Now, naa na po'y problema karon, okay, with regards to protein. So, paano na yung malungkot? Ayan. Okay? So, yung problema naman ngayon with protein is that wala po sa kahit anong set of standard amino acid that is capable of reversible binding to oxygen molecule. I repeat, walang capable, no? With reversible binding sa 20 standard amino acids. Okay, what does it mean? Ibig sabihin lang po, kapag nag-attempt si oxygen na mag-bind to a protein, sakay protein na yan forever. Hindi reversible, di ba? Supposedly, yung goal natin is ma-distribute yung oxygen sa different tissues, sa different cells. Dapat pagdating sa cells, ibigay niya yung oxygen. Yung ginagawa po ng mga amino acid, hindi reversible binding. Kapag nag-bind yung oxygen na yan, sa kanya na yan. Okay, yan yung character ng mga protein, specifically amino acid. Hindi po sila capable ng reversible binding towards oxygen molecule. Okay? So with that, para masolusyonan yung problema na yan, yung second goal natin is dapat yung protein, okay, samahan natin ng tinatawag na prosthetic group. Okay? Prosthetic group. I repeat, okay, yung solution dyan is simply combine, okay, or samahan natin yung protein with what we call prosthetic group. Now, ano ba yung mga prosthetic group? Ang mga prosthetic group, this is said to be the non-protein portion, okay? The non-protein portion, okay, which has a significant physiological role in the body. Now, halimbawa ng mga prosthetic groups, no, available are the transition metals. I repeat, halimbawa ng mga prosthetic groups are the transition metals. Now, in this case, the common, okay, or the usual metal, okay, that is able to bind reversibly with oxygen molecule is the metal iron, particularly the ferrous form of iron, the ferrous form of iron. Nakuha? So I repeat, ang reason bakit nandyan yung prosthetic group kasi kailangan natin ng parte ng protein na kayang reversible binding. Okay? And that part of protein, which is a non-protein portion of that protein is the ferrous. Okay? So, dyan didikit reversibly yung oxygen molecule. Okay? So, yan yung remedy. Kaso, may problema na naman. Okay? May problema ulit sa prosthetic group na yan. Okay? Diba? Yung prosthetic group natin is si ferrous. Meron bang oxidation or oxidative form si ferrous? Yes or no? Based on your knowledge on the forms of iron. Yes, meron, di ba? Tama. Okay? So, yung problema about prosthetic group, it is very potential to undergo oxidation. Okay? Kapag na-expose yan, ang ferrous na yan sa oxidants, okay, that is capable of oxidation. Pwede yang ma-oxidize. And what is the oxidation form or oxidative form of ferrous? Diba? That is ferric. Very good. Now, if ferric will be formed, that is already a more reactive na form of iron, causing oxidative stress. Now, kapag nagkukos yan ng oxidative stress, delikado yan. That might kill the cells. Okay? That might kill cells, masisira yung cells. Okay? So, dapat iwasan natin, no, yung oxidative form ng iron kasi yan yung more reactive form of iron. It's the ferric. Supposedly, yung kailangan natin na form is yung less reactive one. Diba? Yung less reactive, and that is the ferrous. Okay? So, para masolusyonan yung problema naman na to, dito papasok yung third goal. Okay? Yung third goal natin ngayon is syempre, dapat protektahan si ferrous. Kasi nga, prone man siya sa oxidation. Diba? So, protektahan natin siya. The goal is to shield. Tama? To shield or to sequester. Okay? To sequester, meaning to hide. Okay? Or hide the prosthetic group. Okay? So that would be the third goal. Okay? Para protected. Si ferrous para maiwasan itong oxidative stress that might kill the cells. So yung tanong ngayon, how can iron be less reactive? Paano natin ma-maintain yung less reactive form niya? Okay? So yun na nga, protektahan natin siya, okay, ng shield. Okay? Isi-shield natin siya, isi-sequester natin si iron. Okay? And that form, okay, or that shield that I am talking about, okay, is actually a specialized organic ring structure. Okay? Organic ring structure. Okay? And that ring structure, organic ring structure, is what we call the protoporphyrin. Okay? 9. I repeat, yung protoporphyrin 9 dyan, importante to sequester iron, to shield, to protect iron, to make it less reactive. Nakuha? So, yan yung purpose ni protoporphyrin dyan. Okay? So, nasolusyonan na lahat ng problem. Okay? Protected na yung iron. Di ba kailangan natin protektahan si iron para maging less reactive siya. Okay? Ano ba yung role ni iron? Di ba? Siya yung dito magbabind yung oxygen molecule sa prosthetic group na to, 'di ba? This is the prosthetic group, si iron. Diyan magbabind si oxygen. Now, this complex that is formed, okay? That complex formed kapag may prosthetic group, okay? Uh, protected by a protoporphyrin 9. Ang tawag natin, bakit hindi sumusulat? Ayan. Ang tawag natin dito is heme. Ayaw sumulat. Ayan. Okay. I repeat. Ang tawag natin dyan ay heme. I repeat. Kapag ferrous, then you have a surrounding protoporphyrin 9. Okay. Sequestering the iron. Ang tawag sa buong complex na yan ay heme. Okay? So that is why we have this term, heme. Okay? 'Di ba? I told you this is a protein-bound prosthetic group. Kumbaga, sa centermost part ng heme, okay, sa centermost part ng heme structure, you can locate there the iron. Okay? And yung nagpo-protect sa kanya na sobrang laking organic ring dyan, yan yung protoporphyrin 9. Okay? Protoporphyrin 9. And again, that is very important to make, no? That is very important to make the iron less reactive. Okay, so protected siya ngayon from any oxidants, okay, para maiwasan yung pag-oxidize ni iron. Nakuha? Now, with regards to that central iron atom, okay, with regards to that iron atom, it has an observable 6 coordinated bonds, okay? It is consist of 6 coordinated bonds kung saan, okay, yung 4 na bonds, okay, yan ay binubuo ng mga nitrogen atoms. Kumbaga, meron siyang 4 na kapitbahay na nitrogen atoms. Okay? Halimbawa, if this is the, iron, okay, meron siyang 6 na coordinated bonds. 4 dyan, nitrogen. Kapitbahay niya, nitrogen. Saan galing yung nitrogen? Sa structure ng porphyrin ring. Okay, galing yan sa porphyrin ring. Okay, sequestering the iron. And then, yung remaining 2, okay, yung remaining 2 nga coordinated bonds surrounding the iron, okay, you will find out that later. But somehow, you already have an idea ano yung isa. Ano yung isa? Para saan pala dyan si iron ulit? To have a reversible binding with what atom? What molecule? With oxygen. So, alam niyo na yung isa. Alam niyo na yung isang naka-perpendicular bonding or coordinated bonding with iron. Okay? And yung isa, malalaman natin later. Okay? So, for now, just know that it has 6 coordinated bonds, 4 dyan, nitrogen atoms mula sa porphyrin ring. Okay? 2 dyan, okay, will be discussed later. Alright? Next. So, talking about globular proteins, okay? Globular proteins, these are any proteins containing heme, okay? Kapag ang protein contains a heme, okay, you know already what is a heme. Ano yung bumubuo ulit ng heme? Ano yung dalawa na bumubuo ng heme? Dapat merong central na iron at saka merong surrounding na protoporphyrin ring. Okay. So, kapag merong heme, that is also known as heme protein and the globular heme protein. Now, talking about globular proteins I have mentioned earlier. It has two types, myoglobin and the hemoglobin. Okay, myoglobin, hemoglobin. Okay, yung myoglobin dyan, that is important particularly for storage, okay, of oxygen. Okay, then hemoglobin, this is for the transport naman, transport. That's for hemoglobin. Okay, then summary muna, although this will be discussed also later, please take note that talking about a heme, okay, 'di ba yung heme ulit, paulit-ulit ha, meron siyang iron, okay, then meron siyang 6 coordinated bonds, apat dyan, nitrogen. Okay? Now, with regards to a heme, yung myoglobin po, it has, take note, one heme. Okay? Yung hemoglobin, it has one heme. Okay? And then, so kung one heme, halimbawa, this one, this portion here is a myoglobin. Okay? Myoglobin. So halimbawa, on this center part, okay, that is the heme. Okay? That is the heme group. Okay? So yung iron na nandiyan, isa. Ang iron na nandiyan sa myoglobin, isa, particularly sa iyahang heme group. O, yung tanong ko, ilan do you think yung oxygen na kayang mag-bind sa heme group ng myoglobin? Ilang oxygen? Okay? Kaya, ang kayang mag-bind reversibly sa heme group ng myoglobin. Tama, isa lang. Okay? One oxygen, okay, molecule. Kasi nga, isa lang naman yung iron na nandyan. Diba? It has one heme. Now, what did I told you about hemoglobin? Meron ba siya, ano ba yung tawag sa quaternary structure niya? Diba, it is also known as tetrameric siya na protein. Tetrameric protein yung hemoglobin. Okay? Mind you class that hemoglobin meron siyang apat na heme. Sa isang structure ng hemoglobin, meron siyang apat na heme. So do the math. Ilan do you think yung oxygen na kayang i-accommodate ni hemoglobin sa heme group niya? Very good. Apat na oxygen molecule. Kasi, kung sa isang heme, merong isang iron, sabi dito, apat yung heme ng hemoglobin. So, per heme dyan, merong isang oxygen. So, times 4, apat na oxygen molecules. Alright? Now, I have told you earlier that the iron atom has 6 coordinated bonds, right? Now, yung dalawang coordinated bonds ng central iron, okay, that is consist, okay, of the following. Okay, yung 2 remaining coordinated bonds ng central iron, it is consist of the histidine residue. Okay, so that is consist of a histidine residue, or that histidine residue is also known as proximal. Okay, proximal histidine residue. Okay, what do you mean by proximal? I think you know this already sa anatomy. Kapag proximal, distal. Pag proximal, does it imply near or far? Near or far? It is. It implies, tama, near. So for now, tandaan nyo lang, kapag proximal, ibig sabihin near. we will be discussing more, no, deeply with the structure of heme. Okay, yung heme protein. So you will know this, bakit tinawag siyang proximal histidine residue dito. And then, yung sabi ko nga, para saan si iron, okay, it is very important for the binding of oxygen. Kaya yung isang coordinated bond sa central iron is molecular oxygen. Okay? So ulitin natin, you have a central iron, okay? Then it is being bounded there with oxygen, okay? Yung isa dyan, naka-perpendicular, is the histidine. Okay, isang histidine residue. Then yung apat are nitrogen. So, 6 coordinated bonds surrounding the central iron. Alright? Okay. Now, let us now discuss the, ayan, okay, the first type of the globular protein. Okay, so we have the myoglobin. Okay, so unang type muna tayo ng globular protein. Okay, so we have myoglobin. So myoglobin, this is a monomer, okay, monomeric protein. So ibig sabihin ng monomeric protein, isa, no? Monomer, isa. So, ibig sabihin, it only consists of a one polypeptide. Okay, one polypeptide. So, kumbaga, meron kang isa lang po na kahaba-habang polypeptide chain for a myoglobin. Alright, monomeric. Unlike hemoglobin, di ba hemoglobin, you have somehow an idea nga tetrameric yung hemoglobin. So for myoglobin, monomeric siya. And when we check its amino acid sequence or its primary structure, when we check the primary structure of the myoglobin, it has 153 amino acid sequences or amino acid residues. Ako ha, myoglobin, isa siyang protein. Ang bumubuo sa primary structure niya, 153 amino acid. Isang polypeptide chain lang yan. Alright? Now, with regards to the function of myoglobin, this was introduced already. This serves as reservoir or storage of oxygen. Okay, and take note, these are usually or commonly found, no, sa muscle cells. Okay, sa muscles. Kaya nga myo, okay, yung myo, okay, ibig sabihin dyan muscles. Okay, that's why they are found in muscles, particularly heart muscles, skeletal muscles. Please take note, heart muscles, skeletal muscles, myoglobin. Okay. Now, when we check its primary structure, okay, myoglobin, with regards to myoglobin structure, okay, please take note, in general, yung myoglobin structure, ang mga polar amino acid residues niya makikita on the surface. Somehow you know this general knowledge, di ba? Kapag polar hydrophilic amino acid, they are found on the surface, okay, on the outer portion of the protein. Okay, and then generally, yung non-polar amino acid residue naman ng myoglobin sa structure niya, they are found at the interior portion. Okay, they are found in the interior portion. Ibig sabihin, within. Okay, within the protein structure, nandoon yung hydrophobic, non-polar, okay, amino acid. Particularly, these non-polar amino acids are leucine, valine, phenylalanin, okay, and methionine. If you try to scan over your notes on the different examples of non-polar amino acid, pasok yung apat na yan. Leucine, valine, phenylalanin, methionine. These are non-polar amino acid. And again, stated here, generally, they are found at the interior, okay, portion of myoglobin. But we have certain exceptions, okay, for myoglobin structure, ha? We're talking about the myoglobin structure. We have an exception here, okay? We have certain amino acids which are not polar, non-polar, okay? I mean, not which are polar, okay, rather, okay? Which are polar that are found still in the interior portion ng protein. I repeat, meron tayong exception, okay, na mga amino acid which are polar but found in the interior portion of the protein. Okay? And that particular amino acid for myoglobin found in the interior portion of a protein which is a polar amino acid is the histidine residue. Okay? So ito yung exception. Okay? Exception na makikitang amino acid which is a polar one. Okay? A polar one but found within the structure of the myoglobin protein. Okay? Particularly, merong dalawang histidine residue na makikita sa mismong interior portion ng myoglobin. Now, supposedly, di ba, polar sila. Ano yung general knowledge natin dapat sa positioning ng polar and non-polar amino acid? Dapat polar in general nasa surface. Pero yun na nga, exception ito. Exception. Histidine residue lang naman. Histidine residue. Di ba that is polar? Polar siya kasi that is a basic amino acid. Okay, that is a basic amino acid. Okay? Ayan. Okay. Now, still under the structure of myoglobin, please take note with regards naman to their secondary structure. Yung 153, okay, sequence of amino acid, kapag nag-fold yun, nag-level up sila. Okay, nag-level up sila ng structure ng protein. So pagdating sa secondary structure, please take note they form alpha helix. Okay, they form alpha helix secondary structure. Okay, di ba dalawa yung klase ng secondary structure? We have the alpha helix and then the beta sheets. Now, for myoglobin, its secondary structure is an alpha helix po. Alpha helix. Particularly, it forms 8 alpha helices. 8 alpha helical segments. And each of that alpha helices, okay, sa myoglobin structure that is being labeled by letters A to H. Okay, that is being labeled by letters A to H. Ibig sabihin, yung first alpha structure, alpha helix structure, it is named as A. Then the second is B until the eighth nga alpha helical segment as letter H. Okay? That is why nakasulat dito 78%, so majority of the secondary structure of myoglobin, alpha helix. Okay, alpha helix. Whereas the 22 remaining percentage, that is for the turns at saka short loops. Okay, turns and loops. Particularly the beta turns and loops. Diba? These are very important for the connection. It will link the secondary structures together, okay, from one another. That's the importance of the turns and the loops. Okay? And since we're talking about alpha helix here, recall that when we talk about alpha helices, there are certain amino acids that favor destruction of the alpha helix. Naalala? Ano po, sorry. Excuse me. I repeat, merong mga certain amino acids that favor the disruption, okay, or the destruction of alpha helix. That is why hindi sila makikita sa mismong myoglobin structure. So please take note that alpha helical structure of myoglobin will be terminated or will be destructed in the presence of proline. Kasi 'di ba, proline cannot participate hydrogen bonding, particularly intrachain hydrogen bonding. Okay? It cannot participate intrachain bonding. And remember, isa lang 'di ba yung chain, yung polypeptide, yung isang buong polypeptide chain ng myoglobin, isa lang, and that consists of 153. Okay, 153 amino acid. Okay? So yung kapag nag-fold yan, intra-chain hydrogen bonding yung mangyayari kasi isang chain lang naman yan. Intra within that self, magfo-fold yan, intra-chain hydrogen bonding. Okay, kapag nag-level up yan, nag-level up yung primary structure to secondary structure, alpha helix yung form niya. Oh, what is the shape of an alpha helix? Spiral or zigzag? It is very good, naka-spiral. And sabi dito, it will form a total of 8 alpha helices being connected by turns loops. Okay? Then please take note, proline, okay, should not be present, and wala ding makikitang beta bends and beta loops kasi beta bends and beta loops for beta sheets lang po yan. And there is no beta sheet structure or beta pleated sheet structure, secondary structure sa myoglobin, only alpha helices. Alright? Sige. Now with that concept of the structure of myoglobin, let's have this figure. Okay, ito, structure lang din to ng myoglobin, but the application of what I have discussed earlier. Okay, so talking about the primary structure of myoglobin, I'm sorry if I was able to mention hemoglobin, it's myoglobin. Okay, so talking about the structure or primary structure of myoglobin, di ba? It consists of amino acid sequence, and there are again 153 amino acid sequences, okay, or amino acid residues, okay, consisting the primary structure of myoglobin. And we all know that in a primary structure, okay, or in the whole structure of a polypeptide, on the leftmost part niya, 'di ba, doon natin makikita yung N-terminal amino acid. Okay? So, kumbaga, yan yung beginning part, okay, ng myoglobin structure. So, nandito yung free amino group, the N-terminal amino acid until, okay, on the 153rd nga amino acid, doon natin makikita yung carboxyl, free carboxyl or the C terminus. Okay? The C terminal amino acid. Alright? And then for its secondary structure, remember, it will form 8 alpha helices. Okay? So, yan na yung nakikita nyo ngayon. Try nyo bilangin yung mga parang naka-spiral cylinder dyan. 8 yan lahat. Those are the alpha helical segments of myoglobin. And what did I tell you? Yung 8 alpha helical segments of myoglobin, it is being labeled from letter A to H. Okay? Kumbaga naka-classify sila or labeled by letters A to H. Kaya meron kayong makikitang A, 'di ba? C, D, E, until H. Okay? So, that's for its secondary structure. Now, another important feature that you have to take note on the structure of myoglobin is the crevice. Okay? The crevice that we can observe. Particularly, we can observe in the EF. Okay? In the EF alpha helices. Okay? On the alpha helix EF. Okay? So, ito yon, di ba? So, as you can see, in between, no? In between this one, the F alpha helix, okay, and the E alpha helix, meron kang makikitang crevice. When you say crevice, para siyang butas or hole, okay? And that is very important kasi sa crevice na yan, okay, sa EF, kung saan in between EF, yung crevice na yan, that is where the heme is being housed. Okay? Diyan namamahay yung heme. Okay? I repeat, diyan po namamahay yung heme. Ilan ulit yung heme ng myoglobin? Ilan yung heme ng myoglobin? Isa. Okay? Isa lang po yung heme ng myoglobin. Okay? So as you can see here, okay, I will encircle. That part is the heme. Okay? And what consists one heme? What consists a heme? Ano yung structure na makikita doon? Yung kulay pula dyan, yan yung protoporphyrin ring. Protoporphyrin ring. Yung kulay, anong kulay yan? Orange, yellow, basta yung nasa gitna. Okay, yung nasa gitna, that is the ferrous. 'Di ba? Yan yung consisting parts ng isang heme. So yung crevice in between E and F alpha helix, okay? Sa structure ng myoglobin, doon po makikita yung heme. Okay? Now with regards to the with regards to that alpha helix E at saka F, di ba? You can observe there na merong nakalabel na histidine residues. Histidine residues. And I have told you nga yung iron, okay? 'Di ba yung isa sa kanyang perpendicular bond is a histidine molecule, okay, or a histidine residue. Okay? So you can see there the histidine 93 or the histidine F8, that is actually what we call the proximal histidine. Okay? So ako yung circle ha. Ayan. Yung part na to, okay? Ayan. That is known as proximal histidine. Okay? So you have there histidine 93, histidine F8. Okay? So why is it termed as histidine 93, histidine F8? Let's start first with the term proximal. Okay? Histidine. Bakit siya tinawag nga proximal histidine in the first place? Yung parte na yan. Okay? Try to check. Okay? Yung reference point kasi natin dito is the iron. Okay? Yung reference point natin is the iron. If you try to observe the structure, yung pinakamalapit na histidine Okay, between histidine 93 and histidine 64, di ba mas malapit si histidine 93. So siya yung proximal, mas malapit sa iron ha. So siya yung proximal histidine in which siya yung histidine na nakalink, nakabound sa iron. Okay, kaya tinawag siyang proximal histidine. Siya yung histidine amino acid na nakalink sa iron. Okay. Now, bakit naman siya tinawag na histidine 93? Okay, bakit naman siya tinawag na histidine 93? It is because, di ba, we have 153 amino acid residue sa myoglobin. Kumbaga, yung histidine na yan, ika-93rd siya. Okay, sa amino acid. That's why histidine 93. Nakuha? Sa 153 amino acid, yung pang 93rd, it's the histidine. And nagkataon, siya yung nakalinked. Okay, the one that is being linked to iron. Okay? Now, bakit naman siya tinawag na histidine F8? Okay, F8. Now, it has something to do with the secondary structure of the myoglobin, which is the alpha helix. Diba? Talking about the secondary structure of myoglobin, we label them with letters. Okay, from letter A to letter H. O kung bibilangin mo yung F, pang ilan yung F? Diba pang sixth siya nga, alpha helix. Okay, from letter A to letter H, pang 6 siya. So, kumbaga, si histidine, okay, yung F dyan, ibig sabihin, yan yung pang 6th na alpha helix. Okay, sa walong alpha helical segments ng myoglobin, pang 6th po yung F. Okay, na nandoon yung histidine. And then yung 8 naman dyan, mula sa pinakaunang amino acid from that F alpha helix until dulo, pang-8 naman siya. Okay, pang-8 yung histidine, okay, sa mismong alpha helix na letter F. Okay? Ayan. So that's why histidine F8. Okay, yung F, it has something to do with the alpha helix. Then yung 8, pang-ilan siya na amino acid on that alpha helix. Okay, so pang-8. Ayan. So comparing naman to histidine 64, if you compare the distance of histidine 64 to histidine 93, distance nila to iron, malayo itong histidine 64, di ba? From the reference point, iron. Kaya ang tawag naman sa histidine na to is distal histidine. Okay, ito naman yung tawag dito is distal histidine. Okay? Kasi mas malayo siya from the reference point iron. Okay? Or this is also known as the histidine E7. Histidine E7. So no problem ano yung ibig sabihin ng E7 dyan. Okay? It has something to do with the alpha helix, yung letter E. Then pang ilan naman yung amino acid na histidine sa mismong alpha helix nga labeled as E. So, pang 7th. Okay? Ngayon, ano yung role ng distal histidine na yan? Okay? Please take note that the same with histidine 93 or proximal histidine na merong significant role dyan, which is directly bounded siya with iron, si distal histidine din, meron din siyang role, significant role dyan. Particularly, the distal histidine is very important for stabilization of oxygen binding, okay, to iron. Okay, kumbaga, siya yung magsa-stabilize, okay, mag-e-enhance ng affinity of oxygen towards iron. Naalala? Dito magbabound sa iron yung oxygen. So yung gagawin lang po ni distal histidine, stabilization purposes. Iyang gina-stabilize ang oxygen binding towards the iron. Okay? Do you have question with regards to myoglobin structure? Okay. So itong pangalawang slide na to, naka-statement form lang po yung diniscuss ko through pen and board. Okay? So naka-statement form lang siya, 'di ba? Sabi kanina, yung myoglobin structure meron siyang crevice, helices of E and F. Okay, merong crevice, merong hole, okay? Butas, okay? In the helices E and F. Okay? And on that, meron tayong mga notable nga mga structure. Okay? You have the proximal histidine, or that is also known as histidine F8 or histidine 93. Para saan yon? It is the one that is directly linked to the iron. Okay, yan yung directly linked to the iron. Then the distal histidine naman, or also known as E7, okay, siya naman yung nagsta-stabilize ng oxygen binding to the iron. So yun lang po yun. Okay, for that slide. So all in all, we are done with the structure of myoglobin. Excuse me. Okay, we're done with the structure of myoglobin. So let us now proceed to the second type of globular protein. Okay, we have hemoglobin. Excuse me. Ayan. So once again, hemoglobin is very important for transport purposes. Okay, siya naman is for the transport purposes of oxygen. Okay, hemoglobin. Okay, we can realize based on the term itself, no, hemo, na yung mismong hemoglobin is exclusively found in the blood. Kasi pag sinabing hemo, okay, kapag sinabing hemo, it indicates blood. Okay, hemo, it indicates blood. That is why nakasulat, it is found exclusively in red blood cells. Hemoglobin. Okay, and again, para saan? Transport of oxygen. Then later, we will be discussing the behavior, okay, the characteristics of hemoglobin when it comes to transporting oxygen. Okay, kasi when it comes to its transport mechanism, that is highly regulated by allosteric effectors. Okay, yung oxygen binding properties ng hemoglobin that is highly regulated, highly controlled by such allosteric effectors. Okay? Now, with the structure naman, I have mentioned that hemoglobin is a tetramer, particularly a hetero tetramer. This slide was actually presented already when we discussed quaternary structure, di ba? A very common example of quaternary structure of protein is hemoglobin. Okay? So you know already the term heterotetramer. Okay? So I have mentioned earlier, di ba, na si hemoglobin, meron siyang apat na chain. Okay? Based also on its definition, tetramer, meron siyang apat na polypeptide chain. Kapag monomer, mono means one polypeptide lang po ang meron kay myoglobin. Hemoglobin, tetramer, 4 chains, 4 polypeptide chain. Okay? And kung si myoglobin, meron siyang isang chain, and per chain, merong isang heme. Okay? Do the math. Ilan do you think yung Heme, meron si hemoglobin. Okay? Merong apat. Therefore, na heme for hemoglobin. Okay? Hemoglobin. Okay? Now, talking about its quaternary and even sa secondary structure pa lang ng hemoglobin, sobrang different yung structure ng hemoglobin comparing to that of myoglobin. Okay? Secondary hanggang quaternary structure po, malayo, no, sa isa't isa yung structure nila. Okay? Talking about the quaternary particularly, quaternary structure of hemoglobin. Okay? Ano yung tawag natin sa uh, per chain, okay, per polypeptide chain that we locate in a quaternary structure? Do you still remember? Very good. It is subunits, di ba? Tawag natin sa per polypeptide chain in a quaternary structure, subunit. So kumbaga, since we're talking about quaternary structure, we can find subunits in a hemoglobin. And again, ilan ulit yung subunits na yun? Kumbaga, ilan yung polypeptide? Kasi we're talking about quaternary naman, so it would be good to use the term subunit. Okay, parehas lang po yan sa chain or polypeptide chain. So again, merong apat na subunit yung hemoglobin. And sabi, heterotetramer. Okay, heterotetramer. Ano yung apat na subunit na yon? So recall, 'di ba, meron siyang dalawang alpha subunit and dalawang beta subunit. 'Di ba, yan yung tetramer, okay? Or the 4 subunits ng hemoglobin. Okay? And please take note that in each of the subunits, alpha subunits in each of the alpha subunit, there are 141 residues, okay, that are present. There are 141 residues that are present in each alpha subunit. And then for beta subunit, each, okay, contains 146 residues. Okay? So grabe ka, complex talaga no ng structure ng hemoglobin kasi nga nakarating na siya sa quaternary. Capable siya mag-level up to quaternary structure, and we all know that quaternary structure is already the last level for a functional or matured structure ng protein. Okay? So please take note of this number of residues, amino acids per subunits, no? Per alpha subunits, per beta subunits of a hemoglobin. Okay, so since dalawa yung alpha subunit, dalawa yung beta subunit, so it times 2 mo lang. Kung curious ka, ilan yung amino acids, no, present sa isang hemoglobin protein. Okay, so you can simply multiply it by 2. So yan po yung number of amino acids na meron si hemoglobin. Okay, kumpara kay myoglobin, ilan lang ulit yon kay myoglobin? There are 153, di ba? Yung myoglobin, 153 lang amino acid, pero marami na din yan, di ba? 153. And then, with regards to its secondary structure, ano yung secondary structure ng myoglobin? Only alpha helix. Ilan yung alpha helix? Ilan yung alpha helix? Very good. 8 alpha helical structure. Ilan yung polypeptide chain ng myoglobin? Ilan yung polypeptide chain ng myoglobin? Very good. Isa lang po, no, yung chain na meron si myoglobin structure. Kapag nag-level up to secondary structure, it will form 8 alpha helical segments. Okay? Now, with regards to hemoglobin, we have certain terminologies that you must be familiar with, okay, particularly with regards to the subunit composition of principal hemoglobin. Okay, so here we have what we call alpha 2, beta 2. So you know this already ha, basta alpha 2, dalawang alpha helix, dalawang beta. Okay, alpha 2, beta 2. This is the major hemoglobin among adults. Okay, that is the major hemoglobin type, no, ng adults, ng humans. Okay, or that is also known as hemoglobin A or HGA. Then we also have alpha 2, gamma 2. Okay, ito naman ay common sa fetal hemoglobin, or this is also known as fetal hemoglobin. Just be familiar with the subunits, okay, present for each type of hemoglobin. Okay. Then sickle cell hemoglobin, somehow this was discussed no during the discussion na ni Sir Chris Fell katong sa protein folding, sickle cell anemia, 'di ba? So alpha 2, okay, then sickle 2. There is already mutation, okay, sa amino acid residue. Then alpha 2 delta 2, that is for minor adult hemoglobin. Okay, minor adult hemoglobin. Okay? Sige. So, just take note with this slide. Ayan. Okay? Now, let us have the quaternary structure, a deeper knowledge or deeper discussion on the concept of the quaternary structure of hemoglobin. So, recall natin, again, under quaternary structure of hemoglobin, there are four subunits. There are four subunits, apat na chain. Okay, sa buong quaternary structure ng hemoglobin. Now, in some other references in biochemistry, if you try to do an advanced reading or review no, sa inyong references that you have, most of the quaternary structure ng hemoglobin, the four subunits are being classified or categorized. They are being grouped into what we call dimers. Okay, again, they are being grouped into what we call dimers. Dimers, ibig sabihin two monomers. Two monomers. And what is the grouping? Paano nag-group yung apat na subunit? So halimbawa, 'di ba we have alpha 1, okay? Then we have alpha 2, okay? Then we have beta 1. Ayan, beta 2. Kasi nga, dalawa yung alpha, dalawa yung beta. So, four subunits. Okay? Now, with regards to the groupings, okay, ang groupings po nila is ganito. Alpha 1 and beta 1 as one dimer, then alpha 2 and beta 2 as another dimer. Kumbaga, dimer 2. Okay? So, this would be dimer 1, and this one is dimer 2. Okay? Also, this can be named as alpha, beta 2. Okay? Kasi sa dimer 2, you have the alpha 2 and beta 2. Okay? And then the dimer 1, that consists of alpha, beta 1. Ayan. Okay? Now, with regards to the groupings, okay, we can actually observe different forces of attraction. Okay? And you know this already, di ba? Kapag quaternary, tertiary structure na-attain na ng protein yung higher level ng structure nila, there are other forces of attraction that we can observe. Okay? Particularly with hemoglobin, okay, merong mga forces of attraction that we can observe within the dimers or between the dimers. So pag sinabing within the dimers, between this two, okay, between this two, that's within the dimers. Kapag sinabing between, the dimer, so that would be between dimer 1 and dimer 2 na force of attraction. Force of attraction, I'm talking about the bonding. Okay, force of attraction, that's the bonding. Okay, so let's have first the observable force of attraction that we can observe between the dimers. So between the two dimers, we can observe ionic bonds and also hydrogen bonding. Okay? So that is the force of attraction that we can observe between the dimers. And then for the force of attraction that we observe within the dimers, each of the dimers, ang observable naman na force of attraction is the hydrophobic. Pag hydrophobic, polar or non-polar? Polar or non-polar? Very good. It's a non-polar bond. So please take note ha. Within the dimers, hydrophobic force of attraction is highly observed. Then between the two dimers, ionic or hydrogen bond are being observed. Okay? So, itong structure na nasa right side, ito lang din yon. Okay? Naka 3D. Naka 3-dimensional representation lang siya. Diba? You have the groupings, alpha 2, beta 2. This is the beta 1, alpha 1. Okay? Sige. In your slide, if you try to check your slide, merong nakasulat dyan. Yun na din yun, yung na-discuss ko. Okay, mabasa man yata gihapon. Ayan, so, diba sabi, the quaternary structure of hemoglobin, it is a tetramer, diba? It is a tetramer. And meron siyang identical dimers. The dimers are dimer 1, consisting of alpha, beta 1, and then the dimer 2, alpha, beta 2. Okay, mabasa man siya, no? Then, another thing, the force of attraction that we can observe within each dimer, hydrophobic. And then, between the dimers, ionic and hydrogen bonding. So, yun lang yun. Okay, na-discuss na natin yan. Okay. For this 3D structure, same lang din. Okay, recap lang din to na yung grouping ng ng apat na subunits is by dimers, alpha 1, beta 1, then you have alpha 2, beta 2. Okay? And again, there are apat nga for subunits and ilang oxygen yung kayang i-carry ng hemoglobin given that red heme group. Naka-label naman yung mga heme group, 'di ba? Yung kulay red diyan, yun yung mga heme group. 'Di ba? And per heme, isang oxygen. Per heme, isang oxygen ang makaka-bind. Okay? So, total of 4 oxygen can be bounded. Okay? Now, with regards to the hemoglobin structure, okay, meron siyang characteristic conformational changes. Okay? Meron siyang characteristic conformational changes. Kumbaga, si hemoglobin, pwede siyang mag-conform, okay, into a different structure causing deoxidation, oxygenation. Depende yan kung ano yung makikitang abundancy of forces of attraction sa mismong hemoglobin. Diba? I have mentioned forces of attraction within and between. Okay, the dimers. Okay, so these are the two forms of conformational changes that might result to oxygenation or either deoxygenation of hemoglobin. So first up, we have the T form. Okay, the T form of hemoglobin, or this is also known as the taut form. Taut, paano ba yan? Basta same spelling. Okay, taut form or the tens form. Okay, now with regards to the tens form of hemoglobin, what is being observed here is that highly, okay, rich in ionic or hydrogen bonds are being observed between the dimers. Okay, so sobrang daming ionic bonds, hydrogen bonds between the dimers. Now, if that is the case po, more bonds between the dimers, mas sisikip ngayon yung space, no? Sa form, sa structure ng hemoglobin. Now, if sisikip, okay, yung form, okay, yung structure ng hemoglobin, that will cause, uh, it will cause, ang tawag dyan, kumbaga hindi niya ma-accommodate si oxygen kasi wala ng space. Okay? It will cause incapability ng hemoglobin to accommodate oxygen. Okay? Kasi nga sobrang daming network, sobrang daming ionic bonds, hydrogen bonds being observed between the dimers. Sisikip yan. Sisikip yung form, hindi ma-accommodate yung oxygen. Kaya yung nakalagay, this form of hemoglobin causes low oxygen binding. Low oxygen binding. Okay? Kaya, other way to describe the T form, this is the deoxyform of hemoglobin. O kapag de nga prefix, does it implies a more oxygen or empty oxygen? Diba? It implies empty, de, na may removal of hemoglobin. Kumbaga mababa yung hemoglobin. Okay, so reflective lang yan dito. Kasi nga, nagkakaroon ng low oxygen binding kapag ganyan yung form ng hemoglobin. Okay, so that's for the tens form. And then, the other conformational change for hemoglobin is what we call the R form or relaxed form. Okay, so kapag relaxed form naman, what is being observed here is konti lang yung hydrogen bonding na makikita, okay, or ionic bonds, no, na ma-observe sa structure ng hemoglobin. Okay, kung lesser yung bond, may space ngayon, may freedom of movement ngayon, no? May space ngayon para ma-accommodate yung oxygen to the structure ng hemoglobin. Nakuha? That's why this implies na pag relaxed form ang hemoglobin, it will have a high oxygen affinity or binding. Another synonymous ng term ng affinity, binding lang po yan. Ability to bind, no? Binding. Alright? That's why yung nakalagay, oxy form of hemoglobin. Oxy, meaning kaya niyang ma-accommodate man si oxygen if that is the form of the hemoglobin. If lesser hydrogen bonding, ionic bonding is observed. Alright? O, itong structure na to, itong figure na to, this is just a summary of the two conformational changes of hemoglobin. Try ko i-highlight ha. O, halimbawa, this one. Okay? Diba, this is dimer 1. Okay? Meaning it has the alpha, beta 1. Then this is the dimer 2. O, in between dimers, diba, ang atong ma-observe na force of attraction in between dimers are the ionic at saka hydrogen bonds. Now, kung i-compare natin sa kabilang structure, sino yung mas maraming ionic hydrogen bond? Is it letter A or letter B structure? Mas marami yung bonds, hydrogen bonds, ionic bonds. It's the letter A. Therefore, this structure implies nga lesser or lower oxygen binding or affinity yung mangyayari. Kaya nakalagay, this is the deoxy form of hemoglobin. Okay, and then the other one, since lesser yung hydrogen bonding observed, this is the oxyform ng hemoglobin. Ma-accommodate natin yung oxygen dyan with that form. Okay, so that's the difference between the tense form and the relaxed form. Okay, actually pwede na ninyo siya ma-apply sa inyong life experiences. So halimbawa sa klase, hypothetical lang, no? Sa klase, kapag marami kayong iniisip, maraming tense, kapag tense masyado yung utak nyo, pressured masyado yung utak nyo, 'di ba? Daghan man gid huna-hunaon. Then the moment mag-discuss ang teacher, hindi masyadong pumapasok yung mga information kasi nga nate-tense ka, marami kang problema na ginahuna-huna. So, yan yung kapag concept ng tense form. Okay, so pwede na rin siya ma-relate dire. Kapag tense form, deoxy, hemoglobin, mahihirapan si hemoglobin i-accommodate yung oxygen. O kapag relax naman kayo, 'di ba? Pag relax kayo, wala problema. The moment nga maka-receive mo information, dali lang ang absorption, 'di ba? So somehow ingana ang iyang concept de are. Okay, relaxed form versus tense form. Okay, next, ito din, the same lang din. Okay, the same lang ni siya nga concept. It has something to do with the deoxy and oxy formation, only that pinakita lang dito yung mismong iron. Yung kulay yellow dyan, that is the iron, or golden yellow ba yan? That is the iron. Okay, so kapag R state, relaxed state, na-accommodate niya yung oxygen. Yung iron moves into the plane of the heme ring. Effortless. Kasi relaxed state. Then kapag tense form, tingnan, walang oxygen na ma-accommodate kapag tense form. Alright? Now, let us now have the discussion with regards to that binding of oxygen, okay, to the binding of oxygen, both in hemoglobin and also in myoglobin. Actually, we are already done now with the structure of the hemoglobin, okay? That is already the end of the slide for the structure of hemo and myoglobin. Okay? So yung separate segment natin ngayon sa discussion is on the oxygen binding. Okay? Oxygen binding to either myoglobin protein or to hemoglobin protein. Okay? So, yung general concept muna with regards to oxygen binding, okay, with myoglobin and also hemoglobin, please take note, okay, na these proteins, when it comes to oxygen, okay, they either give off or accept oxygen. They either give off or accept oxygen depende, okay, sa surrounding oxygen pressure. Okay, depende sa surrounding oxygen pressure. So I repeat, with myoglobin and hemoglobin, they either give off or accept oxygen in changing oxygen pressure. So yung point lang, again, uh, either hemoglobin, meron silang capability to either give off or accept oxygen. Depende sa abundancy, okay, ng oxygen in the surrounding. Okay, depending on the abundancy of the oxygen in the surrounding. Okay, so let's start first with the behavior of hemoglobin when it comes to oxygen binding. The behavior of hemoglobin when it comes to oxygen binding. So, unahin natin yung hemoglobin bago yung myoglobin. So, please take note, yung hemoglobin, they are capable of what we call cooperative binding. I repeat, hemoglobin, they are very much capable of cooperative binding. Okay, when you say cooperative, marunong siyang makisama. Marunong siyang makisama, okay? Depende sa pangangailangan. Okay? Halimbawa, nangangailangan itong tissue na to ng oxygen, magbibigay siya. Kung sa tingin niya, marami yung oxygen sa environment, kukunin niya. Okay? So parang ganun, cooperative siya. Okay? So depende yan ha, depende yan sa surrounding, okay, surrounding pressure. So, yung dalawang posibleng environment or pressure, pwedeng increase, okay, high yung oxygen pressure, or pwede din naman, okay, mababa yung oxygen pressure. Okay, so yan yung mga kondisyon. Okay, kailan cooperative yung hemoglobin when it comes to oxygen binding. Depende sa oxygen pressure. Okay, so now we will discuss the behavior of hemoglobin per condition. Okay, we will discuss the behavior of hemoglobin per condition. So let's start with letter A. Kapag yung surrounding ng hemoglobin, okay, not the hemoglobin, yung surrounding na meron ay mataas yung oxygen pressure. Okay, mataas yung environment with oxygen. Okay, so halimbawa, in our body, an organ that is rich in oxygen would be the lungs. No? Yung lungs. Siyempre, when we inhale air, talagang mapupunta yan, no? Yung oxygen sa lungs, di ba? So, that is an example of an organ with nga rich in oxygen. So, ang pangutana, ano yung behavior ngayon ni hemoglobin kapag mataas yung oxygen pressure or rich in oxygen yung mismong surrounding? Okay? So, please take note, the hemoglobin, it will accept oxygen. Okay? It will accept oxygen. Nakuha? So, kumbaga, sa lungs, okay, you have there the lungs, okay, kapag andyan si hemoglobin ngayon, okay, yung gagawin niya, since marami yung oxygen sa environment, cooperative binding man yung meron sa kanya na ability, di ba? So, iti-take advantage na yan. Marami yung oxygen, edi kukuha siya ng oxygen. Okay? So, it will accept oxygen. So, for this structure of hemoglobin, di ba, it has 4 heme. Tama? 4 yung hemes ng hemoglobin. So, per heme, kayang mag-accommodate ng isa. So, 4 lahat yung oxygen. Okay, so parang ganyan yung gagawin niya until ma-fully saturate siya. Okay, so yan yung aim niya. Kapag mataas yung oxygen pressure, hemoglobin will be saturated. Okay, hemoglobin will be saturated. Saturated meaning full pack ngayon yung hemoglobin, fully filled with oxygen. Okay, yung hemoglobin. Okay? So yung realization natin dito, for hemoglobin to acquire saturation, okay, it requires high oxygen pressure. Okay, so yan yung behavior ni hemoglobin kapag mataas oxygen pressure. Marami yung oxygen in the environment. Okay, next. Paano naman kapag mababa yung oxygen pressure, okay, sa mismong organ or halimbawa sa mismong cell? So, a good example of part sa body nga ang lesser yung oxygen quantity are those tissues. Kaya nga 'di ba ang mga tissues very needy sila ng oxygen. They require oxygen kasi wala silang oxygen masyado. That's why they require oxygen for survival, yung different tissues in our body. So halimbawa yan na may mababa yung oxygen pressure. Okay, halimbawa yan ng environment na mababa yung oxygen pressure. Ngayon, the question, what will be the behavior ng hemoglobin kapag dumating siya sa tissues na lesser yung oxygen pressure? Okay? So this time, since lower oxygen pressure, 'di ba, cooperative binding ulit si hemoglobin, marunong siyang makisama. So si tissues naninghahanglan man siya, okay? Naninghahanglan man siya, naga-require siya og oxygen. So yung gagawin ng hemoglobin, it will give off. Okay? It gives off oxygen or it will donate oxygen na meron siya. Okay? Donates oxygen or gives off oxygen. So halimbawa ulit, okay, you have hemoglobin. Ayan, hemoglobin, 4 yung heme niya. So meron siyang oxygen. Pagdating sa tissues, okay, okay, makikipag-cooperate siya with the tissues kasi kailangan ng tissues ng oxygen. So it will give off or donate that oxygen na meron siya. What do you think will happen if that is the case? Do you think ma-empty yung mga oxygen kapag lesser yung oxygen pressure? Yes or no? Empty kaya ngayon yung hemoglobin? Or less saturated yung hemoglobin? Yes or no? Kapag mababa oxygen pressure. So very good. Yes, may empty ngayon yung oxygen. So lesser saturation for oxygen, less saturated. Okay, that's the behavior of hemoglobin. So very cooperative siya when it comes to oxygen binding. Okay? Kumbaga, pag mataas yung pressure, kaya niyang mag-bind with oxygen, kaya niyang kumuha ng oxygen, it will strongly bind to that oxygen to attain full saturation. Kapag naman may kailangan no, ng oxygen, halimbawa sa tissues, okay, it can easily remove naman the oxygen. Okay? Attaining less saturation. Okay? So with that role no of hemoglobin, we can really say na pang-transport talaga yung role ng oxygen. I mean, ng hemoglobin rather. No? With this concept that we have discussed, when it comes to oxygen binding ng hemoglobin, pang-transport purposes talaga si hemoglobin. Diba? What about the myoglobin? Okay, let's proceed to the behavior naman ng myoglobin when it comes to oxygen binding. Okay. Take note, Okay, take note class that with regards to myoglobin, okay, unlike the hemoglobin, it is not capable of cooperative binding. That's the character, the behavior of myoglobin. Okay? Hindi siya capable of cooperative binding. Kumbaga, madamot siya, no? Si myoglobin. Madamot si myoglobin. Unlike hemoglobin. Okay? Kahit ano pa yung pressure sa surrounding, okay, hindi niya talaga ibibigay yung oxygen na meron sa kanya. Okay? So whatever the pressure, either high or low oxygen pressure, yung si myoglobin, it really attains its full saturation. Kasi nga, sa kanya lang yung oxygen. Okay? Sa kanya lang yung oxygen. O, ilan ba yung kayang i-carry na oxygen ni myoglobin? Very good. Isa. Kasi isa lang yung heme, di ba? It has one heme per heme. Isa lang naman yung iron. So, isang oxygen yung molecule na magbabound sa one heme of that myoglobin. Nakuha? Ayan. So, halimbawa, I'll give you a scenario. Halimbawa, si myoglobin. Si myoglobin to, meron siyang isang oxygen, tama? Isang oxygen molecule bounded to it. And then we have here the tissues. O, kapag tissues, needed, do they require oxygen or not? Do they require oxygen or not? Require, tama. So they require kasi mababa yung oxygen pressure sa tissue. So kapag dumating dyan si myoglobin sa tissues, okay, kahit nangangailangan pa si tissues ng oxygen, hindi po yan magbibigay si myoglobin. Hindi siya cooperative binding. Pero kapag mataas naman yung pressure, wala din siyang gagawin. Okay? Hindi naman niya kayang ma-accommodate ng more than one oxygen, 'di ba? Isa lang naman. So talagang sa kanya lang yung nag-iisa niyang oxygen. Kaya, we can really say nga, for what purpose lang talaga si myoglobin? For, very good. For storage purposes lang talaga siya. Okay? Kasi nga, it does not have a cooperative binding property. Okay? So, for this slides, okay, recap lang din to. Okay? Kung ano yung diniscuss ko sa pen and board, ito lang din yon. No? Diba sabi, myoglobin for storage. Tama. Okay? It can bind only one molecule of oxygen. Tama. Diba? One molecule of oxygen lang ang meron sa kanya. Kasi one heme group only ang meron kay myoglobin. Okay? So, yan, naka-highlight. It can strongly bind, okay, to the oxygen even at very low pressure. Okay? 'Di ba? Hindi katulad ni hemoglobin, kapag feeling ni hemoglobin mababa yung oxygen pressure sa surrounding, si hemoglobin ibibigay niya, 'di ba? Ibibigay niya yung meron sa kanya na oxygen. Unlike si myoglobin, talagang gusto talaga niyang strongly bounded si oxygen kahit at very low pressure. Kaya, meron tayong concept dito stated na at 1 torr, okay? Torr is a unit of pressure, ha? Okay, at 1 torr, that is a very low pressure. 1 torr nga lang, di ba? That is a very low pressure. Okay, that's a unit of pressure, ang torr. Okay? Na-attain na niya yung 50% saturation kahit 1 torr pa lang. Okay? Halimbawa, on the graph on the right side, try to check. Halimbawa, yung nasa baba, this is the oxygen pressure. Okay? Oxygen ng surrounding or environment. And then dito sa y-axis, saturation. Okay? As you can see on the graph, even at a very, ayan, small, not small, low pressure, low oxygen pressure, very low pressure, tingnan nyo, na-attain na niya yung 50% saturation. Kasi nga, hindi niya ibibigay yung oxygen na meron sa kanya. Okay? Kaya, saturated lang pa rin siya with oxygen. Filled pa rin siya with oxygen, even at low pressure. So, the more oxygen, okay, in the environment, okay, mas lalong masasaturate si myoglobin, 'di ba? So yan, that is why it does form a hyperbolic shape when we graph, no, when we graph the oxygen binding of uh, oxygen binding towards the myoglobin, it does form a hyperbolic graph. Okay, hyperbolic graph. Yan yung form ng hyperbolic graph. Okay? Then, ito naman, this is for hemoglobin. So, recap lang din to for transport purposes din siya. Okay? Transport purposes naman siya. Okay? Transport purposes. So, take note, it has the ability of both, di ba? Meron siyang ability of both binding strongly to oxygen. Okay? So, kumbaga, kapag mataas yung oxygen pressure, di ba? Ano yung gagawin ni hemoglobin? It will accept oxygen. Kasi marami yung oxygen sa environment, cooperative binding siya, iti-take advantage niya yun. Parang opportunista din si hemoglobin, di ba? So, iti-take advantage yan, a-accept niya yung oxygen kasi marami yung oxygen sa environment. So, it will bind, kaya niyang mag-bind strongly to oxygen at that case. And then, the other behavior ng myoglobin, it can release oxygen easily. O, ito naman nangyayari kapag high or low pressure. Kanang capable siya to easily release oxygen, high or low pressure. At okay, very good. Ano ba? Ano ba talaga? High or low? Ulit ha. Kailan yung behavior ni oxygen na magre-release siya ng oxygen. Madali siyang mag-release ng oxygen kapag high yung oxygen pressure or low yung oxygen pressure. So very good. Kapag mababa yung oxygen pressure, so halimbawa sa tissues, 'di ba? Sa tissues, low yung oxygen pressure, low yung oxygen doon. So, cooperative binding ang meron si hemoglobin. Nanginahanglan si tissues. Kulang ng oxygen, ibibigay niya yan. It will release oxygen easily. Okay, so that's why it has the ability to both bind strongly to oxygen and then release oxygen easily, depending on the changing oxygen pressure. Nakuha? So ito, na-discuss naman to for oxygen binding site. Kasi nga, meron siyang apat na heme. Diba? Merong apat na heme yung hemoglobin. And with regards to the curve or graph that we can form with regards to oxygen binding to hemoglobin, it will form a sigmoidal shape. So yan naman yung sigmoidal shape ng graph. Okay, sigmoidal shape. Magkaiba sa hyperbolic kasi hyperbolic parang ganito. Okay? Yung sigmoidal may paganyan. Okay? So sigmoidal for hemoglobin. So halimbawa ulit, this is the saturation, yung nasa y-axis. Sa x-axis naman, the oxygen pressure ulit. Okay? So kung titingnan nyo yung graph, okay, at low, okay, tingnan ha, at a very low pressure. Okay? Low pressure. Low yung number of oxygen sa environment. Kumusta yung saturation ng hemoglobin? Mababa din, no? Mababa. Kasi nga, ibibigay niya yung oxygen sa may kailangan. No? At low pressure, it will release the oxygen. Cooperative binding nga. Okay? Then as we go up, no, kapag the more oxygen pressure, yun na nga, maa-attain niya yung full saturation. Okay, yun lang din yung concept kanina. Diba? Kapag marami yung oxygen, okay, in the environment, ano yung gagawin niya? Accept oxygen. Fully saturated. Okay, saturation will be attained. Okay, so hindi sila katulad ni hemoglobin. So that's the reason, pang-transport talaga si hemoglobin, transport of oxygen. No, ito naman, the same lang na concept na sa na-discuss ko kanina. Ano nga ulit yung graph for myoglobin? Sigmoidal or hyperbolic? It is hyperbolic. Very good. Kapag hemoglobin, sigmoidal shape. Okay, sigmoidal shape. O, tingnan ulit para ma-reinforce, di ba? Okay. Kasi repetition is learning. Okay. Sige. So, ulit, oxygen pressure, yung nasa baba, saturation. Okay. Yung nasa y-axis. O, tingnan. At very low pressure. Okay. Low pressure. Kumusta yung myoglobin? Okay. Yung saturation ng myoglobin, tingnan. Ayan. Na-attain na niya yung 50% saturation. Okay? Whereas, si hemoglobin, okay, ito, at this point pa, no? At this point pa, tsaka niya maa-attain yung 50% saturation. So, meaning, at more oxygen pressure. Okay? Tsaka niya maa-attain yung saturation. O, kung mababa naman yung pressure, okay, mababa yung pressure, kumusta yung saturation ng hemoglobin? Ito. 'Di ba? Mababa din. Kasi nga, ibibigay niya talaga yung oxygen kapag low yung pressure. Okay? So, hindi pa niya ma-attain basta-basta yung saturation. Okay? So, that's the behavior of hemoglobin versus to that of myoglobin. Let us continue discussing the behavior of particularly hemoglobin, especially with its ability of cooperative binding of oxygen. Mind you, class, that cooperative binding, that is synonymous to the term heme-to-heme interaction. Again, it is also known as heme-to-heme interaction. When we say heme-to-heme interaction, it means that binding of oxygen at one heme will lead or result to enhance affinity of the rest of the oxygen to the other heme groups of hemoglobin. Okay? In other way of saying that, halimbawa, you have the hemoglobin, recall that it has 4 heme. Okay? Now, whenever one oxygen binds to the first heme of hemoglobin, I repeat, when there is one oxygen that binds to one heme group of hemoglobin, that will lead to enhance or increase binding of the rest of the oxygen towards the remaining hemes of hemoglobin. That's heme-to-heme interaction. Kumbaga, yung concept dito is follow the leader. Yung one oxygen molecule, okay, that first bind at one heme will lead to enhancement of the binding capacity or affinity of the rest of the oxygen towards the remaining heme group of hemoglobin. Okay, so that's heme-to-heme interaction. Now, when we talk about cooperative binding or cooperative interaction, there are certain terminologies that you have to take note and for you to understand as well. Okay, now I repeat, when we have hemoglobin, sabi ko kanina, there has to be a leader. Yung leader na yan, yung unang molecule na yan or ligand na magbabind sa one heme group of hemoglobin, susunod na yung iba. Follow the leader. Now, itong unang ligand that binds to the specific site of hemoglobin, okay, that is termed as modulator. Okay? Ang tawag dito na ligand ay modulator. Yung nag-i-influence sa binding capacity ng other ligands or other compounds to the heme group. Okay? Or that is also known as allosteric effector. Okay? Now, ang tawag naman doon sa second sites, ito, yung mga natirang sites, the first, the second, the third, the fourth heme site of hemoglobin, yung second site kung saan magbabind yung the rest of the ligands towards the portion of heme group ng hemoglobin, ang tawag sa second sites are allosteric site. So, mga allosteric site po yung labeled with red. Okay? Allosteric site. The second site where the remaining ligands bind, okay, to the remaining three heme groups of hemoglobin. Okay? Now, when we talk about cooperative interactions, we can further classify them depende kung anong klaseng ligands or compounds or molecules na nagabind sa heme group ng hemoglobin. So we have two classification of cooperative interaction. So we have number one, homotropic interaction. From the word homo, meaning one, uniform, okay, or the same. Therefore, kapag sinabing homotropic interaction, lahat ng apat na ligand na nagbind sa heme group ng hemoglobin are the same. Okay? The same. Yung four ligands na yan. That's why nakalagay, interacting sites of hemoglobin all binded with the same ligand. So halimbawa, yung leader, okay, would be oxygen, okay? Therefore, the binding of oxygen at one site on hemoglobin, that will influence also the binding affinity of the rest of the oxygen, okay, towards the other remaining sites of hemoglobin. Okay, so kumbaga, kung ano yung modulator, okay, kung ano yung modulator, okay, nga nagbind sa unang site, interacting site ng hemoglobin, yung remaining three ligands na magbabind, the same with a modulator. Okay, the same sa leader. So, homo, the same. Okay, then we also have the heterotropic interaction. Now, this is obviously, okay, a different ligands already binding to the interacting sites of hemoglobin. Okay, hetero means different. Okay, so this would mean that the modulator that bind to the specific site of hemoglobin is different now, no, from the other, okay, ligands binded to the three remaining interacting sites. Okay, so you have a different modulator, then different din yung three remaining ligands na nagbind, okay, sa interacting site ng hemoglobin. Okay, now let us have a deeper discussion on the two types of interaction, two types of cooperative interaction. So again, we have homo, okay, and then hetero. So recap ulit, when I say homo, the four ligands that are bounded are the same. And then pag hetero naman, different. yung modulator sa remaining 3 ligands na magbabind sa remaining interacting site ng hemoglobin. Okay. Now, with regards to these two types of cooperative binding, this might cause or lead to certain effects. Okay. Homo or hetero cooperative type of interaction, they lead to a certain effect. Una, let's have homotropic, a homotropic interaction. Homotropic interaction, in general, this leads to a positive effect. Okay, this leads or results to positive effect. When we say positive effect here, we are simply saying that kapag nangyari yung homotropic interaction sa hemoglobin, it simply enhances oxygen binding. Kapag sinabing positive effect, there is enhancement of the affinity or the binding of oxygen towards the heme groups of hemoglobin. Okay, and that is the good effect, kaya nga positive effect. Whereas kapag naman heterotropic interaction, this may lead to two possible effects. Okay? Pwedeng positive effect, okay? Or the most common one kapag heterotropic interaction occurs, negative effect will happen. Okay, negative effect. This is the most common kapag heterotropic interaction. So balikan natin yung positive effect. With regards to positive effect, enhance oxygen binding lang din po. Okay? Enhance oxygen binding din. Okay? Yung ibig sabihin ng positive effect. Kapag naman negative effect, the opposite one. Okay? Nagkakaroon dito ng lesser oxygen binding sa heme group ng hemoglobin. Yung oxygen, kumbaga, cannot be accommodated by hemoglobin. Okay? Kasi nga, lesser yung affinity ng oxygen to the hemoglobin, the heme portion of hemoglobin. Okay? And that negative effect could cause, okay, health risks, no? Hindi siya magandang effect. That is why on the preceding slide, magfo-focus tayo on the negative effect because this has to be compensated. It has to be solved. Okay? Kasi nga, with this effect, nalilesen yung accommodation ng hemoglobin towards oxygen molecules. And remember, oxygen must be carried by the hemoglobin for it to be distributed to the different tissues in the body. Okay? Now, for this slide, ito lang din yung na-discuss ko kanina. Pag homotropic interaction, positive effect. Okay, wherein you have there enhanced binding of oxygen. So, yan lang yun, homotropic effect. Whereas, kapag heterotropic interaction, di ba, dalawa yung possible effect. We have the negative and the positive heterotropic effect. Okay? Now, with regards, focusing now on negative heterotropic effect, recall nga this causes lesser binding of oxygen. Now, for us to understand why negative effect happens, why there are possibilities na hindi maa-accommodate ni hemoglobin yung oxygen, dapat malaman natin kung ano yung mga certain factor or what we call negative modulator that causes negative heterotropic effect. So, naalala yung term na modulator. Modulator, yan yung unang ligand na magbabind, di ba? Sa interacting site ng hemoglobin. Okay? So, these are what we call negative modulator. And dapat malaman mo ano yung mga example. You have to recognize what are those examples of negative modulator for you to know that if that is available, negative heterotropic effect will happen, causing lesser oxygen binding. So, take note, examples of these negative modulators, negative allosteric effector, we have the protons that is the H plus, the hydrogen ion. Another negative modulator is the carbon dioxide. Also, kindly add carbon monoxide. And we have the 2,3-bisphosphoglycerate. All these are negative effectors, negative modulators that results to less oxygen binding, decrease of binding affinity ng oxygen. Okay, so we will discuss each of these negative modulator for us to understand bakit sila nagkukos ng negative effect. Paano sila nagkukos ng pagbaba ng binding affinity or binding capacity ng oxygen to the heme portion of the hemoglobin. Okay? So I repeat, we will discuss that four mentioned negative modulators kung paano sila nagkukos ng less binding affinity of oxygen. So number one, for this slide, this is all about the proton. Okay? Now, how does proton causes negative heterotropic effect? Okay? Please take note na kapag proton, okay, yung negative effect niya is what we call the Bohr effect. Okay, kaya nakasulat, this is the effect of the binding of proton, okay, causing lesser oxygen affinity to the hemoglobin. Okay, so yung ginagawa ni proton kapag available yung proton, enhance yung proton or let's say masyadong acidic yung environment, 'di ba? Related to sa acidity. Kapag acid, there is H plus. H plus acid. Okay, so low yung pH. Now, with that, kapag present yung proton, ang ginagawa niya, it simply displaces the oxygen being carried by a hemoglobin. Kaya 'di ba, nakalagay dito, you have there an oxyhemoglobin meaning a hemoglobin with a carried oxygen. Kapag may proton present, dinidisplace niya yung oxygen. Kaya sa product side, tingnan, yung oxygen is already unbounded. Free na yung oxygen, unbounded to hemoglobin. Okay? Kaya nung nangyari sa hemoglobin, naging deoxyhemoglobin siya. And 'di ba kapag deoxy, walang oxygen ngayon. Walang oxygen, removed yung oxygen from the hemoglobin. Okay, therefore, kapag deoxyhemoglobin, wala na ngayong oxygen carried si hemoglobin. And if that happens kapag may proton na nag-interact kay hemoglobin, that will not allow already the oxygen binding to that particular hemoglobin. Okay? Kaya it will really lessen the oxygen binding affinity, no, towards the hemoglobin. So yan yung tinatawag na Bohr effect. Kapag Bohr effect, related yan sa proton. Okay? Next, we also have the carbon dioxide. The binding of carbon dioxide to hemoglobin. This is also another negative heterotropic effector. Please take note that we have two reasons, okay, or two mechanisms bakit yung carbon dioxide nagkukos siya ng negative heterotropic effect. So number one, yung carbon dioxide, yung ginagawa niya, it lowers the pH. Kapag lower yung pH, taas or baba yung H+, 'di ba? Taas yung H+. Merong availability nga ron ng H+. So, sulat nyo, H+, taas. Okay? Kasi nga, it lowers the pH. Acidic ngayon yung environment. Kapag mababa yung pH, mataas yung H+. Therefore, it is also somehow related lang din sa Bohr effect. Kasi pag may presence of hydrogen, proton, yung nangyayari, it lead to deoxyhemoglobin din. Deoxyhemoglobin. Kaya nakalagay dyan, Bohr effect. Okay. Second, carbon dioxide participates in the formation of carbamates. Now, mind you, class, kapag yung carbon dioxide leads to formation of carbamate, ang nangyayari sa reaction dyan, nare-release or it causes freeing of proton ulit. So, kumbaga, meron na namang available na proton kapag na-form yung carbamate. Okay, when carbon dioxide participates in the reaction. And again, kapag may proton ulit, that contributes to Bohr effect. Okay? So, dun lang din siya mapupunta. Deoxyhemoglobin lang din. Okay? Kaya, carbamate formation caused by the binding of carbon dioxide that favors the deoxy form of hemoglobin. Kung saan, hindi na ulit ngayon ma-accommodate ni hemoglobin yung oxygen. Okay? So, in general, we can say then na kapag may carbon dioxide bonding, okay, binding, and also presence of proton, all these are collectively known as Bohr effect. Okay? Kaya 'di ba sa previous slide nakasulat binding of proton and carbon dioxide leads to less binding affinity of hemoglobin. Okay? Now, kapag less ulit less binding of oxygen, hindi ngayon ma-accommodate ni hemoglobin yung supposedly oxygen na dapat niyang i-carry. Okay? Kaya, yung magiging effect sa graph, okay, let's have this graph. Okay? Kung titingnan natin sa plot, okay, di ba recall kapag kapag hemoglobin, yung effect, yung plotted graph niya, it forms a sigmoid graph, sigmoidal type of graph. Kaya sigmoidal graph yung pinakita dyan because it has something to do with the hemoglobin. Now ngayon, kung titingnan natin yung graph, basing on the pH, di ba? Kung ito yung pH 7.6, okay, versus the graph with the pH na 7.2. Kapag 7.2, that is already a low pH, no? Based on this figure. Sabi dito, low pH. O ano sabi natin kapag low pH, mataas yung proton level. Okay? Or let's say there has something to do with carbon dioxide kasi kapag may carbon dioxide, it leads to availability of protons, so low pH din. So yung effect nito sa graph, okay, with proton and carbon dioxide, it will cause shifting of the graph to the right. Okay, shifting of the graph to the right. 'Di ba? Kung i-compare natin yung graph, yung dalawang graph, itong basic graph, pag naging lower yung pH, nag-move ngayon yung graph to the right. 'Di ba? Gumalaw yung graph to the right. Kasi yung nangyayari dito, para ma-compensate ng katawan, okay, yung nangyayaring low or less oxygen binding, we should require now greater oxygen pressure. Okay? Para ma-achieve ngayon ni hemoglobin yung sapat na oxygen saturation. Okay? Again, nag-move to the right yung graph kasi it will now require greater pressure, okay, to achieve saturation with hemoglobin. Okay? Kasi with greater oxygen pressure, di ba, rich oxygen sa paligid, i-accept yan ngayon ni hemoglobin para ma-achieve niya yung full saturation. Yan kumbaga yung ginagawa ngayon ng hemoglobin to compensate sa nangyayaring less oxygen binding caused by proton and carbon dioxide. Okay, so shift to the right yung graph. Okay. Next, let us proceed to the third negative effector. Okay, so we have the carbon dioxide. With carbon dioxide, it binds tightly to hemoglobin, forming carbon monoxyhemoglobin. Okay, yung point lang dito with carbon dioxide is that yung nangyayari kapag yung hemoglobin, meron siyang na-feel ng presence ni carbon dioxide, hemoglobin will now have a greater affinity towards carbon monoxide. And its affinity ngayon ng hemoglobin towards carbon monoxide po is 200 to 250 times greater than oxygen. Kumbaga, mas attracted si hemoglobin kay carbon monoxide. Kaya nga 200 to 250 times greater affinity than oxygen. Ano sabi natin kay carbon monoxide? This is a negative modulator. It causes negative heterotropic effect. It causes less oxygen binding. Therefore, fatal yan, di ba? Kasi pag hemoglobin, na-feel niya yung presence ng carbon dioxide, between the two, between oxygen molecule and carbon monoxide, mas maa-attract siya, mas dadalhin niya ngayon yung carbon monoxide. Yung mangyayari kay oxygen, hindi siya makikarried by hemoglobin. Ano ba yung normal dapat na ginagawa ng hemoglobin? Carrier siya ng oxygen. Okay? So, this is a negative heterotropic effect. Okay, and as a treatment for that problem, okay, during carbon monoxide poisoning, kasi fatal gas yung carbon monoxide. So during carbon monoxide poisoning, the best treatment is of course oxygen therapy, or what we call hyperbaric. Okay, hyperbaric oxygen therapy. Hyperbaric oxygen therapy. Okay, that's for carbon monoxide. And lastly, we have the 2,3-bisphosphoglycerate, or this is also known as diphosphoglycerate. Bi or di, that's the same. Okay, bisphospho, diphosphoglycerate. Now, with regards to this negative modulator, yung ginagawa naman niya, it binds strongly to the T state, the tense form of hemoglobin. Okay, I repeat, it binds strongly, it has greater affinity towards the tense form of hemoglobin. Recalling the tense form of hemoglobin, di ba, that is the deoxy form of hemoglobin. Once ang 2,3-bisphosphoglycerate binds to the tense form of hemoglobin, that will already retain, or the T form state of hemoglobin will be remained. Okay, it will not be conformed back to its relaxed form once 2,3-bisphosphoglycerate will be bounded to the tense form of hemoglobin. So mananatili, okay, yung T form, masastabilize yung T form, which is hindi yan magandang form or state ng hemoglobin kasi this is the deoxy form of hemoglobin, meaning to say hindi accommodated dyan yung oxygen if that is the form of hemoglobin, reducing now the oxygen binding affinity of hemoglobin. Okay, so itong second bullet na discuss na yan. Okay. Now with regards to the increased concentration of 2,3-bisphosphoglycerate, when you say increased concentration of bisphosphoglycerate, please take note that there would be lesser oxygen binding. Okay, the same with the mentioned negative modulator. Magkakaroon ng less oxygen binding, lesser yung accommodation ng oxygen sa mismong heme group ng hemoglobin. Now, this case kapag increased concentration ng 2,3-bisphosphoglycerate, this is usually observed on the following condition. Kapag may chronic hypoxia, high altitudes, yung nagte-trekking, umaakyat ng bundok, di ba pansin nyo, hirap huminga, it's because of the increased concentration of 2,3-biphosphoglycerate, lesser oxygen binding, kaya hirap huminga. Okay, during trekking, high altitude. Okay, then chronic anemia as well. Okay, kaya yung graph shift to the right as well. Okay, shift to the right to compensate, no? To compensate that less oxygen binding. So, kailangan ng oxygen, higher oxygen pressure to saturate, okay, the oxygen in the hemoglobin. Now, let's have a review, okay, before we proceed to the next slides. Okay, review natin ulit yung mga negative modulator. Diba, we have carbon dioxide, the carbon monoxide, yung acidity. Okay, or this is related to the proton, no? Proton lowered yung pH. The diphosphoglycerate, okay? Aside from that, kindly add na lang also in your notes, although these are not agents, these are not compounds that bind to the hemoglobin, but this has something to do with the activities na ginagawa ng tao, which also causes less oxygen binding. Okay, so kindly add, we have exercise, okay, exercise, and also kapag mataas yung temperature, okay, mataas yung temperature, that also enhances, no, the lessens the oxygen binding rather. Okay, kapag mataas yung temperature in the environment, less oxygen binding will happen. So yung mnemonics ko dito is cadet right. Okay, cadet right. Yung right, that only help me be reminded nga yung graph shifting to the right, no? Yung graph is shifting to the right to compensate, no? The lacking, okay? Nga, or the less oxygen binding. Kailangan ngayon ng greater oxygen pressure para ma-attain yung saturation. Okay, so cadet right, carbon monoxide, carbon dioxide, yung acidity related kay proton, the diphosphoglycerate, exercise, and enhanced temperature. Now, if you understand the concept on the effects, no, or caused by those negative modulators, you will understand these memes. I extracted this memes sa biochemistry, no, nga mga memes. So, halimbawa lang ha, if you really understand it, memes lang naman ito. Okay? Applying what you have learned sa 4 modulators and the heterotropic effect. Okay? So, halimbawa, you have a crush. So, yung crush mo is si hemoglobin. Okay? Kumbaga, yung girl that you like, halimbawa, is the hemoglobin. Okay? Or the other way around. Yung hemoglobin, huna-hunaa siya as your crush or someone that you like. The girl or boy that you like. Okay? Siya si hemoglobin. And then, yung X ng crush mo, is the carbon dioxide. This is a negative modulator. It causes lesser affinity. Tama? Yung brother niya is the bisphosphoglycerate, another negative modulator. Nagkukause din ng lesser affinity. Okay? Yung boyfriend niya ngayon, ng babaeng gusto mo, which is si hemoglobin, is si carbon monoxide. Ano yung affinity ni carbon monoxide? 200 to 250 times, di ba? Greater, okay, than oxygen. Ikaw, oxygen ka lang. So, tangtang yun ka sa story per me. Okay, kung oxygen ra ka, tapos na ay mga negative modulator. Kasi this negative modulator, di ba, will lessen your affinity towards the girl that you like, which is the hemoglobin. Di ba? So, you can try, no, search for more memes sa biochemistry. You follow sa Facebook, mga biochemistry memes. Kaya you will at least apply what you have learned sa ato ang class. Okay? And yung iba, nakakatawa. Ito, nakakatawa, di ba? Nakakatawa siya if you understand. If you understand the concept. Pag hindi mo naman na-understand, yun yung problema. Okay? Dira na ka makulbaan. Okay? Sige. Okay. For the remaining 3 slides, dito naman i-discuss natin yung mga conditions, okay, yung mga sakit in relation to hemoglobin. Okay? So kapag nagkakaroon ng mutation, okay, yan nakalagay, mutant human hemoglobin, meaning to say there is already mutation or alteration sa structure, sa functioning ng hemoglobin, and that leads to disease, that leads to a certain condition. So halimbawa, methemoglobin. Yung nangyayari sa methemoglobin, yung supposedly ferrous na form of iron as prosthetic group in the heme portion of hemoglobin naging ferric. No, ano sabi natin sa ferric? Di ba this is a more reactive form of iron. Okay, and that is not supposedly the iron form that must be present in the heme portion of hemoglobin kasi that will cause oxidative stress. Okay, that will cause oxidative stress. So that's what happened kapag methemoglobin. Ferric, okay, yung present na iron sa heme than ferrous. Then we also have hemoglobin M. Dito naman yung nangyayari yung proximal, naalala yung histidine F8, di ba yan yung proximal histidine? It has been replaced by tyrosine. So yan yung nangyayari na mutation. For hemoglobin S naman, this has something to do with sickle anemia. Ano yung nangyari kay sickle anemia, di ba? Valine has replaced glutamic acid. Kasi sa normal nga uh, amino acid sequence sa red blood cells, di ba, glutamic acid yung dapat na andoon. Kaso, kapag naging sickle cell anemia, yung glutamic acid, it has been replaced by valine. Okay, kaya nakalagay, valine has replaced glutamic acid. Then we have myoglobinuria. Okay, myoglobinuria. Ito naman, presence of myoglobin in the urine. Okay, there is presence of the myoglobin, okay, in the urine. Now, if ever myoglobin is present in the urine, that characterizes damaged muscles. Okay? Kapag nagkaroon ng damage destroying of muscles, nasasama sa ihi yung muscle cells. Okay? So that's for myoglobinuria. Then we also have anemias. We have a lot of types, no, of anemias. Maraming klase ng anemia. Now, talking about the nutritional anemia or nutritionally related anemia, pwedeng yung anemia is caused by deficiency of iron. Okay? Deficiency of iron. Kaya meron tayong tinatawag, di ba nga, iron deficiency anemia. Kaya, usually, nagtitake ng iron supplements. Okay? Kapag anemic ka. Kasi, with iron, okay, na-enhance niya yung synthesis ng hemoglobin. Kasi this is a very important part ng heme of hemoglobin, yung prosthetic group nga, iron. Okay? Also, vitamin B12, deficiency of vitamin B12, and also folic acid. These are underlying causes ng nutritional anemias. Okay, so kindly take note. Then we also have thalassemia. Sa thalassemia naman, yung nangyayari, there is an absence, pwedeng one or more alpha, okay, or alpha chain of hemoglobin, or beta chain of hemoglobin. Kapag nagkaroon ng absence of alpha chain, okay, that is known as alpha thalassemia. Kapag naman absence partially or total ng beta chains of hemoglobin, beta thalassemia. Okay? And then yung glycated hemoglobin, this is used for the diagnosis of diabetes mellitus. This is used for the diagnosis of diabetes mellitus.